Okay, let's start the video. For the next hour and 5 minutes, we're going to be watching the time-lapse assembly of the QMX Plus by qrp-labs.com. And as you could see me put on my anti-static wrist strap, I take static protection, anti-static protection very seriously. Now, Hans recommends a jeweler's loop. I prefer the jeweler's stereo glasses, as I just demonstrated. They have a loop on one side. Now I'm getting the capacitors all out to sort. I wasn't that anal compulsive about pre-sorting them, and so I just went ahead with the assembly. His markings in red are the same markings as on the capacitor, which makes it fairly easy to follow. And as you can see, my head is bobbing in there some, looking to make sure everything's going okay. I took and stuffed all the capacitors in the board before I began any soldering. This 1 hour and 5 minute video took place over 3 video sessions and totaled over 16 hours of actual work time on assembling the board. I had heard one gentleman had assembled his QMX Plus in 8 hours. Maybe the next one I build I'll get it down that low, but it took me about 16 hours of construction time, 16 hours 42 minutes to be more precise. And that was one of the capacitors that had to be spread a little bit before it got in the hole. And I continue my work. I wanted to make sure and check everything off as I put it in there. And so you see me right with there. I checked that the capacitor is the right value, has the right numbers written on it, and check it off in 2 different places as I stuff the board and as I locate those number of capacitors. So the capacitor installation went quite straightforward. I did make one mistake. When I had opened the package, there was a hole in it. Some of the packing tape stuck to one of the bags inside the kit, and when I opened the package, I accidentally cut open the storage bag for the parts. When I did that, a couple of capacitors fell out and I put them back in the wrong bag, and consequently I had to go out and buy a couple of capacitors, not realizing that they were in the kit, just not in the same bag that I put them in. Oh well, we live and learn. And the construction goes on. I'm actually making pretty good time with the capacitors there. I had set a stopwatch out so you could see the real elapsed time, but in this shot it didn't show up. When I build the next one, I'll make sure I show the real time clock and the elapsed time in the build. I'm doing this at 16x time, and so the 16 hours and 42 minutes, and 49 seconds. 16 hours, 42 minutes, 42.49 seconds according to my timer clock. And so it takes just over an hour and a half to do the time-lapse video. I'm getting the soldering equipment there, if I'm recalling correctly what went on. I turned the board over to start soldering things and had to get the soldering equipment there warmed up and ready to go. Some of this I went downstairs, as the ham shack is on the second floor, and I went downstairs to take a little bit of a break and neglected to turn off the video, so we're just sitting here looking at a time lapse of the desktop with nothing going on. It's been 6 minutes times 16, that'd be about an hour and a half, just over an hour and a half. Of elapsed time. And I'm doing this voice over late on a Sunday afternoon, Sunday the 10th of November. Started about 8 o'clock. Hopefully I'll get this done by 9 o'clock and get some sleep going. I should be coming back here before too long to continue the soldering. I may have even gone down and eaten dinner without the view of the real-time clock showing a local time. It's hard to remember what actually went on, but I got all the capacitors stuffed. I rotated the board over and was going to solder it, and that should begin taking place here just shortly. The kit was constructed in Butuan City in the province of Agasan del Norte, Caraga region on the island of Mindanao in the Philippines, but I'm now in the United States. I completed the construction just before I had to leave to go catch the plane, and after the construction I have not even powered it up yet. I put it all together and slid it into the case to protect it while it traveled, put hot glue onto the coils to hold them in place because I knew it would be vibrating on the plane for a long time before I got here to the mainland United States. And I'm in Eugene, Oregon now, and I'm back starting to solder in that. I just saw some shadows of my arms moving over, and I straightened the board around, so just shortly here we should see some more action as I continue the construction. I'm quite impressed with the quality of the board, and as I said, I used a wrist strap as the board was. You can see the wrist strap on some of the shots, the blue wrist strap on my left arm. The bag that the circuit board was shipped in was anti-static, so I figured I would use my anti-static mat, which is underneath the instructions, and my blue anti-static wristband to reduce the possibility of any static damage on the board. The human model for anti-static is 15 picofarads in series with 10 k ohms. The 10 k ohms is mainly skin resistance, and the 15 picofarads is how much energy your body can store. I had to suck a little excess solder off there, and I've got them all soldered and trimmed away. And then you can, as you can see, I'll take and pick it up and inspect it pretty well. Had to touch a few of those up, putting the jeweler's glasses on and straightening up a few of the capacitors, resoldering some stuff, and I took inspecting all the things and doing a little solder sucking when there was too much solder there, and looking some more. Wanted to make sure everything was soldered good before I went on to the next stage of the build. After this, I think I put in all of the inductors, but I was marking them off on the schematic as I did them, and as you can see, I saved all of the trimmings. Oh, it's the 1 in 4007s that I'm putting in next. I took all the trimmings from the capacitors and put them in the plastic bag to save them, and he recommended doing some tests, so I'm checking all the diodes to make sure they're going in the right way. It wasn't real obvious from the picture which direction the anode of the capacitor went, but after checking with the multimeter and bending all of them, I figured out which way they were supposed to go. I find it curious that on a diode, the cathode is marked the same way as the anode is on a hollow state device, so I find that even after so many years in electronics to be somewhat confusing. But I got all of the diodes installed and clipped, and I'm inspecting them with my jeweler's glasses and doing a little more soldering there. That blue soldering iron that I'm using is a 60-watt unit, I think, and I bought it at the local electronics supply, Trimix, run by a man named Mr. Lim. He's since transferred the ownership to his daughter, Jenalyn Joy C. Lim. And one thing I really like about living here in the Philippines is you can go into the electronics store and buy just one resistor or one capacitor or one diode or one LED at a very reasonable price. And so it makes getting parts like the 2 capacitors that I misplaced, I was able to easily get them. I'd made a mistake there and had to desolder something, and they didn't have any solder wick, and so I was using some stranded copper wire that I had to unsolder the device that I thought was in error, but it turns out it was an instrumentation problem. The leads on the DMM had oxidized a little, and so I wasn't getting a good reading. After checking that, I realized, oh, it was just the meter after pulling the device off the board. But we live and learn. I'm installing the inductors now in the switching portion of the low-pass filters, and that goes really fast. The instructionists are nowhere near like in a Heath kit. He tends to do things in bulk installs, which makes the construction go a lot faster. You can see the blue anti-static strap on my wrist there. I took an accidentally broke one of the inductors. Fortunately, I had a stash of inductors in my shack and was able to replace the broken one that I checked with a meter there. Now I'm installing the BS170 transistors in the output stage. I bent them a little close, so I had to get a bigger washer to hold them down. I didn't want to try and unbend them and bend them again, and I wasn't satisfied with how well that smaller washer was holding, so I left my jeweler's glasses and wrist strap and went downstairs in my workshop area to get a bigger washer. I found a bigger washer and I put it on there, and away we go. Got the BS170s tightened down and soldered in. Load up all of the excess ones. You can see the broken inductor there. Somehow I managed to break it when I was installing it, and now I'm getting ready to wind some of the coils. The first coil I wind is the output transformer, and I use the really weird twisted sisters technique for winding that. I brought my drill along and wind that. So I was checking the number of turns per millimeter, per centimeter, and it seemed to go well. Compare the picture to what I actually wound. Everything seemed to go well, so I took and put a piece of double back tape in between the ferrite and the board, so it would tend to stick it down to the board and make it more mechanically secure. You can do that if you'd like. Also, afterwards I took and hot glued all of the coils because I knew it was going to be put in a box and on an airplane vibrating for a long time. It was about an hour and a half flight between Butuan City and Manila, and then 10 hours from Manila to Honolulu, 45 minutes back to Kauai, about 4.5 to 5 hours from Kauai to Oakland, and then here to Eugene, another few hours in the air. So it was getting plenty of vibration testing, and I wanted to make sure everything was mechanically secure. And so, as well as the double back tape on the flat ferrites, I took and put hot glue to hold things down as well. You'll see that later on in the video. Yeah, I was taking and scraping the enamel off of the wires to make it a little easier to get them to take solder, but everything seemed to work okay. I had excess solder and then sucked it out, and this is the first one of these kits I've built. I plan on selling this one to a friend who's interested in it, and then I want to build another one. I had that much fun. Doing some more soldering there. I'll try and get a better camera angle next time. Now this is the one where I had instrumentation problems. It's so humid in Butuan that everything oxidizes very quickly, and there was an intermittent on that, and I thought it was in the transformer, but it turns out it was the connection between the test lead and the meter. And after I discovered that, I put the transformer back on and everything continued as planned. I had left the leads really long on the transformer and didn't trim them off till after I did the ohm check, and that made it a little easier to get back in after I'd pulled it off the board. And I would recommend that when you solder the transformers in there, make sure the continuity is good before you cut the leads off, because it's a fairly trivial task to remove the transformer with the leads long and reinstall them. But if you cut the leads short, it'll be a lot more of a pain to put it back in the board if you make a mistake. Now, there was the bag of inductors that I happened to have in the shop, and I had the value to replace the one that I had broken. And then I came back with the capacitors that I had purchased there, actually ceramic capacitors instead of plastic like the ones that came with it, because they were older stock. They pretty much make everything out of ceramic now, except for, everything out of plastic now, except for high voltage capacitors. You'll still get ceramic occasionally, but it costs so much more. You can see there in the middle two capacitors that I replaced with locally available caps. And then it was well after I had started winding coils that I found the two missing capacitors, and the ones that I had purchased locally for only about 10 or 12 cents each. Did I find the other capacitors, and I wasn't going to change those out. I figured the ceramic capacitors would perform just as well as the plastic ones. Now I'm putting the output transformer back in, and had to clean out the holes some with the solder sucker, and then I was pulling on the wires to make sure that they're tight in there, and to pull the coil up against the board. I'll be more careful next time, and I don't think I'll make that same mistake again. I was concerned because the resistance readings weren't reading as shown in the diagram, so I pulled the transformer off and then realized that there was a problem with the meter. There's where it shows where all the resistance readings are, A to A and A. And everything seemed to go okay, so I carried on with starting to wind coils. A note about winding coils: there's only two ways you can wind a donut toroid. It's with the first wire going down and then working the coils counterclockwise, which is the same as starting with the wire going up and going clockwise. Down counterclockwise is the same as up clockwise, and then up counterclockwise is the same as down counterclockwise, if that makes any sense. I'll have to write that out. So if you're left-handed and want to wind these coils, rather than counterclockwise, anti-clockwise like Hans recommends, you could hold them in your right hand and go bottom up clockwise, and it will make the coils physically the same as the first winding down, and the coils progressing anti-clockwise. And then I was taking and scraping off excess flux. I'm starting to wind the other coils. I did the output transformer, which is the first one. Took my coil off, my anti-static strap off, and took a little bit of a break. And sorted out the coils, coil forms, the ferrites, and then began winding coils. You'll see me get out the measuring stick. It's actually a right angle. It's a square with metric marking on it, so metric and English marking, so I was able to measure the wire and start winding coils. Because I'm not working directly with the board, I didn't put the strap back on until I start putting the coils in there. You can see me threading and pulling and threading and pulling. This goes so fast it's hard to see what I'm doing, but I'm counting coils, and I came to realize that it was easier to, rather than count it physically, I just laid it down and took a picture of it with my camera and blew it up to make the coil count easier. Because you take a picture and you're already getting about 2x magnification, and then I was able to count the coils on the coil numbers on the camera rather than physically as I started out. That was kind of how the assembly progressed. I was working and learning as I was going. Ticking on the keyboard a little bit. I was looking to make sure my recording program is going. Special thanks to Peggy Mulder for the use of the MacBook Pro. I'm watching this video on YouTube without any audio and recording the voiceover on GarageBand. So that's what's going here. YouTube's already counted one view on this thing. So I'll finish this voiceover and then put the voiceover on the video and re-upload it. I'll have to download the video. I was having trouble transferring the time lapse from the Android into the MacBook Pro, so I just went ahead and uploaded the time-lapse video without any audio onto YouTube, and I'm watching that they are doing the time-lapse, and then I'll download that video and add my voiceover audio here from here that's made in GarageBand. I'll take the GarageBand audio and put it with the video in the movie program. What is it? iMovie. And then we'll all be done with it. We're about halfway through the hour's worth of time-lapse video. Hopefully it's not too boring. Listen to this American old man talk about the kit that he's building. left my anti-static strap and tools there. I've obviously gone off to take another break. Just sat down and moved the paper, so very shortly the construction should continue. There's about 12 coils to wind. Let me see, 2, 4, 6, 8, 10, 12, 14, 15 coils you've got to wind. The winding of the coils went very smoothly. My fingers were beginning to get a little bit sore from holding the toroids and pushing the wire through. So some of the time I was holding it in the toroid in my right hand and holding the wire with my left hand, but all in all it went fairly smoothly. The coils that it's showing in the middle, 405A and 405B, kind of went to lay over, and I laid them at a slight angle before I put the hot glue on it to mechanically hold them in place. The coils that lay flat, coil 31, 30, and 44, I didn't put any hot glue on because the flat ones are not an issue with vibration. But if you're going to be carrying this around and doing POTA, which I'm hoping to activate POTA from Jurassic Park in Buena Vista in Agusan del Norte sometime in February or March, and if you're going to throw it in your backpack and go somewhere, you might want to think about using some hot glue or something to hold the coils that are stacked on edge. Otherwise, my concern is that the vibration will cause the wires to break coming off the coil. But with the hot glue on there, it provides enough mechanical support to where that should not be an issue. And I just took a picture of that coil, and I'm counting the turns on the phone, which you can't really see. That I think that is the low pass coil, the band pass filter coil for the receiver. A couple of years ago, maybe even before the pandemic, I built HF Signals U-Bit X, and there you could see me take the picture. And technically this QRP-labs QMX Plus is much better radio in that it has band pass filters on the receiver. I live in an urban area, and there's a lot of high-powered medium wave AM stations transmitting. There you can see me counting the coils and making sure everything's good to go, and taking some more pictures and counting again, and measuring some more wire to wind another coil. I take and wind 2 or 3 coils before I put them on the board. And I also do some tailoring work, so working with my hands and winding coils is not that much different than working with my hands and pulling thread slightly thinner than the wire that these are wound with, but everything seems to work okay. I'm double counting all of the number of turns on the coil. And especially if you're my age, if you're younger, you could probably just look at the coil directly, but it seemed to make a lot of sense to me to take a picture of it that was magnified, and then I could count the number of coils. And there I'm sending myself a note on my daughter, Georgine, some information about what I'm doing. I tried to get her interested in ham radio. She's artistic and likes to paint, but so far I haven't been able to get her into ham radio. For a while she was using the app Morse Toad, which teaches Morse code, but she's gone off to college in Florida to study nursing, so I was sending her a message there. I knew several times I had taken breaks in the build, but I didn't realize they were quite so long. Next time I do this, I'll be sure and shut the time-lapse video off when I leave the work and then restart it when I come back. My concern was that when I would come back, if I didn't restart the video, I'd be losing some of it. Winding another coil there and taking a picture of it and counting the number of turns. Yeah, Hans has done a very good job of designing this radio. I'd be interested to see what the MDS and Intermod third order intercept products of this radio, as I'm going to be going to Colorado Springs, and I was thinking of getting a hold of Ron Sherwood to see if he could make some measurements on this, but that's yet to be seen. I started an email to him but haven't finished it. I'll have to get that sent off to him. I leave Eugene here on the 15th, next Friday, to go to Colorado Springs and visit some friends that I worked with in the Marshall Islands, and I thought it'd be hopefully easy to get with him. He's officially retired, but maybe he'd make one more measurement. I know that he's added some new ones like the FTDX10 and the ICOM 7300, IC 7300 recently, so maybe he'll be able to make some measurements on this. I would rather think the way Hans had designed this, it would have a very good IP3 rating. The anecdotal stories I've heard that the QMX would copy signals that an FT7300 would not copy. I rather imagine that's because of the 24-bit sound card he has in it. But I would be very interested to see what the IP3 on this receiver is, and what the MDS of the reading I've done. I haven't seen any of those numbers that Hans has published, but I'm sure it's quite sensitive enough for QRP radio. The thing about a QRP radio, if you're a little bit deaf, it's actually to your advantage, because then you'll only hear the stronger signals that would more likely be able to hear your QRP signal. That's not entirely the case in FT8 or any of the FT modes, but just a point that I was making. And there I'm winding and measuring and cutting wire and taking pictures and counting turns. I took and distributed some of my still pictures to various friends on Meta Facebook Messenger. So they got some of the near real-time work that I was doing. I don't know if I could live stream the build as well as do a time lapse, and probably take 2 cameras to do that. I have to look at that next one of these I build. I'm getting all the coils in there and all the coil wires plugged in and tightened up, and pulling on them to make sure that they're snug, doing the soldering. I can't say that soldering iron is the best one I've ever had, but it seems to work okay. Took something off the board there. I don't remember exactly what the problem was there, but I desoldered it and sucked the hole out and resoldered it. I have to look and think about that some more. Something with one of the coils. Don't remember exactly what. Pulling the wire tight with my needle nose pliers to make sure everything's up against the board good. I was a little bit overwhelmed at the number of coils I'd have to wind, but it actually turned out to be not a problem. I was encouraged that one builder was able to complete the build in 8 hours. It took me twice as long as that. As I said before, 16 hours and 42 minutes and 42 seconds. My timer watch. Checks, but everything seemed to check okay. And the coils are all getting in there. I kept leaning back in my chair and not keeping my hands where the camera could see me, so I had to consciously reach my hands out onto the desk to make sure you could see where the coils were. There, I took some more pictures and counting coils, coil turns in both directions. But 8:45 a.m. alarm went off. There, I've got all the receiver coils done. Now I'll move over to the low-pass filter boards, low-pass filter coils in the transmitter side. He has you wind the 160 meter coils first, so you do all the coils with a greater number of turns before you work your way up to the 6 meter coils, which means progressively as you're winding coils, you're winding less and less wind, so it does seem to make it go a little bit faster. But the first coil up in the upper left that you can see is one of the 2 coils in the 160 meter low pass filter, and then the blank ones to the right work their way up through 80, 60, and 40, and on up to 6 meters. Yeah, it takes, like Han said, it takes a lot of heat to melt the enamel off of the wires, but once you get it going, it's okay. I found that once you stick the coil wire through the hole, if you take and lay it down flat and scrape it just a little bit with a safety knife to get just a little bit of the enamel off of there, you can get a little bit of heat into the wire, and it makes the enamel burn off a lot faster rather than if you just try and heat the wire through the enamel. It does work that way, but it takes a lot more heat and a lot more time, so I would bend the coil wire over and scrape it just a little bit, so once I started putting solder into it, the wire would get hot more quickly and burn the enamel off. And then I cut the wires loose on that one and do all the ohmmeter checks. Scrape a little bit of the flux off with the safety knife. So I got 3 of the 12 coils installed, taking a little bit of a break, starting to wind some more, take pictures of the coil, count the coils, coil turns, verify it's the right number of turns, count it in both directions, and then stuff it into the holes. I was sending copies of the pictures to myself on Meta Facebook Messenger. Meta Messenger chats, it's called by various names. I got 4 of the 12 coils done, and verifying again the turns counts by taking a picture and counting it on the phone. Just a note about that pointy device I was using there. When I was working in two-way radio, we would have to trim the length of the vertical whip that would install on the mobiles, and the little round piece at the end was the anti-static coil. You can see the Allen wrench there. So I took a hollow ground piece of scrap stainless steel antenna and screwed one of the anti-static balls onto it and use it as a poking tool. I've got several of those. Those are GE style antennas. The Motorola antennas you tune from the bottom side, and the anti-static balls are hard pressed onto the antenna. The GE ones use a machined ball with an Allen set screw. And there I'm doing some more. That's the tri-filler coil there. There was a bit of a jump there. We got the last 8 coils installed rather quickly. I think that was some of the work I did with the time-lapse camera turned off, so it went from 4 coils to all 12 in a very short period of time. I did the tri-filler wound coil and ohmed it all out and laid it out, took pictures, counted the coils, make sure everything was in line, and send myself a copy of the picture for historic reasons, so that would be in the archive. So I have an archival copy of what it is. Also, after I finished the construction, I took pictures of the actual board, so I could do yet more forensic study, make sure everything's as it should be. And there it is, just about with all the coils there except for the output VSWR coil. And I'll take and wind that next. Pretty straightforward. 10 turn windings on both sides, and then a one turn winding on through each hole. So that goes pretty straightforward. But there again, I'm doing quality assurance with taking pictures and counting turn numbers, and I'd set a real-time clock. See there, you can see me cutting up the double back tape, getting it ready to stick on there. I'd put a real-time clock and my elapsed time clock, but they're just off to the left of the screen. I couldn't see the screen of the time-lapse camera real well, and so I missed the fact that those clocks weren't showing up. Next time I'll make sure the real-time clock and the elapsed time clock are showing, so you can get an idea of what time of day the events are taking place. The last little bit of this that I was building, I woke up at about 2 o'clock in the morning before my flight left at 7:30. I'd set the alarm for 4, but I'm glad I woke up before the alarm and wanted to finish this so I could have it all boxed up and not need my soldering iron and tools. I did finish so late I wasn't able to power it up, but everything is there, and I check out all the solder joints. There's only about 12 minutes left in this. Time-lapse video, and I'm doing another little bit of a video to, I mean a bit of a text to my brother-in-law. In any event, I'm getting down to the connectors. I take and bend the connectors to give some mechanical support on the power jack. I was a little concerned if it would line up right, but it did. One of the cardinal rules of soldering is mechanical support before soldering, and I was trying to do that with the power jack because that and the antenna are going to be the ones that the most stress is put on. The microphone and headphone jack are going to also have some stress on it, and I bend those around once I put that addendum board on there. And I'm even getting the back plate out so I can check to make sure everything fits. But the build, all in all, went very smoothly, except for the mistake I made in thinking the coil was bad and pulling the coil off the board because of the test equipment leads not making good contact into the meter. I didn't have any problems at all. We'll have to comment after the rig gets powered up how it goes. I'm anxious to get it powered up, but don't have a 12-volt supply. I built this radio for nominal 12 volts. I didn't want to do the 9-volt though. That would give you some more headroom in some ways, but I wanted the 12-volt version. I'll have to take and add about 3 diodes in series with it when I run it off the power supply at the home shack, because the ham shack power supply puts out between 13.8 and 14.2 volts, so too much for the 12-volt rig here. I'm taking and installing the jacks on the extension board for the headphone and key, and using some of the spare leads to get that all put in there, and beginning to solder those in. I soldered some on the outside to make sure it was gonna fit. By the outside I mean some of the ones on either side of the row of pins, and when it was all firm together, I took and bent the rest over and soldered them, and that went really well too. When I did the assembly on the LCD, there was some differences in the way that I did it than the way he recommended. There was the way Hans recommended it. You had to solder the back side of the LCD connector while it was installed on the front panel. I didn't much like that, so I made sure everything would fit, and then laid the connector down and soldered it before I put the connector onto the back board. So I deviated some from the recommended assembly procedure so that I could see the connector where the solder was going to flow, rather than have to solder it blind behind the panel, which I didn't much like that when I was reading the instructions. So yeah, I took and plugged all of those connectors into the board where they would mate, and then slid the display board onto there and soldered them while they were mated, rather than solder and then mate them. I wanted to make sure that those connectors were lined up properly before I put the solder in. And I started soldering the push buttons in, and you have to note that there's 2 pins that you don't solder. I went ahead and didn't solder all 4 of the push button contacts. The rotary encoders have 3 encoder pins and 2 switch pins, so there's 5 pins on the encoder. Because of the mechanical configuration of the display board, you have to wait to solder those after you put the screws in. And I was soldering, sanding everything to make sure everything would fit good. I was screwing that stuff together to make sure it'd fit. Oh, there was one plastic piece missing. I'll take credit for losing that. But I had some plastic that I cut down, and then that's part of what I was soldering, what I was sanding on, so that everything would fit nicely. And I take and screw it together, and then I solder it before I put it Hans recommends soldering it while it's put together, but I wanted to be able to see the solder joints as I soldered them, see that the solder was flowing, so I did it in a slightly different sequence than he recommended. I'll maybe have to make a real-time video of doing that on my next build. Yeah, I've already got a local ham, Delta Whiskey 9 Alpha Zulu uniform is going to buy this rig. I'm going to just sell it to him for what it costs to replace it. I'm not going to charge him for any of the construction build. And Oscar had already ordered a different QRP rig, but for some reason his order got canceled, so that's when I offered to sell this to him for what it will cost me to replace it. I ordered the GPS receiver and experimenter's board as well, but Oscar won't be using those, so I'll deliver it to him just with the minimal equipment in it. Now there I was getting it all screwed together. I haven't soldered the connector on yet, but I put it all together and then solder it where I can see the connections, because Hans recommends screwing it all together and then soldering it between the front aluminum panel and the connector, and I didn't find that appealing at all, so I took it apart. Granted, doing it this way is a little bit more work, but I wanted to be able to see the solder joints as I flowed them, and so I took it apart to do that soldering after installing the connector. Actually, it's a header pins, not really a connector, and took it apart so I could see where they were soldered. Then I put it back together and soldered the inside most pin. I had to tighten all those up to make sure the standoff nylon washers were where they needed to be, and got it all screwed back together. And even at 16x, I tried some of this at 32x, and 32x was just too fast, so I went ahead and did 16x. Now I'm beginning to solder stuff and giving it the thumbs up that the ohmmeter check went good, because you can't see the meter. Now I'm soldering the inside part of those header pins. I put it all on there, put the buttons on, put the knobs on. He recommends putting the screws from the knobs and tightening them down to the round portion and not the flat portion. What that does is it makes the knob sit a little better and it on center, so it doesn't wobble as much as if you screwed the set screw down to the flat portion. And about 3 minutes left of the video. I think I went downstairs to get the hot glue gun, so I think, and find some small screwdrivers to tighten the screws down and make sure the knobs were the right distance. Probably on the next one I'll take and make a little shim so I can get both knobs exactly the same amount. Now I'm taking my last QA pictures to get good pictures of all the coils, and then fit check it into the box. I had forgot to break off the wings on the display board, so eventually I get my pliers and break off the wings. You can see the hot glue gun heating up there, and I wanted to mechanically secure all of the coils before I brought it here to the States with me.